So we're currently standing at the entrance of Suicide Basin, Mendenhall Glacier. And what you see up there is a remnant Suicide Glacier. As recently as 40 years ago, this glacier was flowing into the basin and filling this entire basin with ice. So we start accumulating water in late fall, early winter. The water keeps coming up, and then if it happens like last year, it might actually overflow over the ice dam for a couple hours, couple days. And then all of a sudden the lake is finding a way, it's finding a crack, like a conduit, and the water starts flowing through this crack. If you ask me today when it's going to drain, it's really hard. We probably know it's going to happen within the next month, but it totally depends on the weather. Is it going to be rain? Is it going to be warm? How much water is flowing into the lake? That's a key question. And then the lake can actually also drain at low levels. So we can do certain things using models, but it's very important to have equipment out here that looks at the actual process and just documents it.
Really what we use the information from Suicide Basin for is advanced warning, alert and notification. It gives us an extra 24 to 36 hours to be able to alert homeowners that the water levels in the river basin are rising. So it gives them time to plan accordingly, to sandbag around garages and door entryways to keep water out of their homes.
So one of the big questions that we have for this project is, how much water do we actually store in this basin? How's this basin going to look next year? How's it going to look in 5 years? And to figure out these answers, we use, for example, drones. So we use drones to fly over the basin, take pictures every 2 seconds in our case, and then we process these pictures to get elevation models for a certain time. And if you compare these elevation models over time, we can actually determine how fast the ice dam you're standing on, how fast it's thinning. There's a sensor that is sitting in that lake in there and measuring the water pressure and thus the water level at a certain time. Then we have the camera, it's visible right there, sitting on the slope of the mountain. That's a time-lapse camera that's looking at the basin and tracking how the ice in the basin is evolving over time. Yeah, so what we have learned from previous measurements is that the ice dam has been thinning pretty rapidly, kind of reducing the volume of water that can be stored behind the ice dam. But we have also measured that the ice in the basin is melting even faster than the dam here. So if these two competing processes, one is actually reducing the potential volume of water that's stored, and one is increasing the volume of water that can be stored in the basin. And right now we're still in the process of figuring out which one is actually stronger. But what we're going to see into the future, we see this ice dam melting probably at a similar rate, 4 to 5 meters per year. And we'll also see the ice in the basin melting very quickly.
The Suicide Basin program has been a great showing of partnerships in the region of Southeast Alaska. It's really nobody's job to monitor this particular situation, but through working with the university, USGS, the National Weather Service, and the city, we've all found a way to chip in, and we've been able to create this program to monitor it. It's really provided some great real-time information for our community. It's allowed people to mitigate the loss of flooding in their homes, and it's allowed the community to prepare. It's really been a wonderful partnership, and we can't thank our partners in that.